So we'll start with what the alternating series is. So here's a very typical example of the alternating series, and it's alternating because the signs are changing between positive and negative between each term. The sigma notation of this particular example would be sigma of n with the starting point at 1 to infinity of 1 over n, and we have to have something to change the sign between positive and negative, so that'll be negative 1 to the n plus 1 in this case, and that's because the sign would have to alternate in between every term. So n plus 1 is having every odd term be positive and every even term be negative. So we plug in n here, it would be 1 times negative 1 to the second power, making it positive 1, which is our first term. So the general form for any alternating series would be sigma n equals 1 to infinity minus 1 to the power of n bn. The negative 1 would be the alternating factor, the bn would be the actual term, and from 1 to infinity of course is the range. So typically, to find out if a series is alternating or not, there is two conditions that it would meet. The first one would be that bn plus 1 would have to be less than the term bn. The second condition would be the limit as n approaches infinity of bn, our term, would have to equal 0. The first condition shows that the terms are getting progressively smaller, and the second condition is showing that they would eventually reach 0. So this shows convergence among alternating series. So let's look at an example to see if these two conditions apply to it and to see if it converges. So this example from the textbook, it's chapter 11, I think number 3 in the questions. So we have 4 over 7 minus 4 8 plus 4 over 9 and it goes on. So the first step here would be to put this into sigma notation, so it'd be easier to find bn. So it looks like this series starts at 7. From 7 to infinity. And the bn term would be 4 over n, because we're starting from 7. And the alternating part of this sequence would be negative 1. And to an even power, it would make the term negative, and to an odd power, to an odd power it would make the term negative, and to an even power it would make the term positive. So since the first term is positive, we'll raise it to a positive power, 1 plus n. So now that we have the formula here, the sigma notation, we can start with the first test, which is to see if the n+1 term is bigger than the base term. So that would be 4 over n+1 so less than or equal to bn, which is 4 over n. So this is 4, and n+1 is 7. n+1 is 7 plus 1, which is 8. And this term has to be less than the base term, which is 4 over 7. And this turns out to be right, so the first condition for convergence is met. Now the second condition, we'd have to check if the limit of this term goes to 0. So we have to check the limit as n approaches infinity of 4 over n. So we're checking if this term here, if the bn term, would equal 0 as n approaches infinity. And it's pretty obvious here that as n increases and goes towards infinity, if it increases to 100,000, 10,000, and beyond, then that would be 4 over a very large number, which would make this term go to 0. Because the bigger the denominator gets, the smaller the entire fraction will get. So eventually it would go to 0, and the second condition is met. So this sequence here is convergent. Both of these conditions are met, and this does go to a finite number, so it's convergent.